Good afternoon, Anna, everyone. Yeah, thank you. Are you chatting with me only or with your friends? Okay, good afternoon. Right. Yesterday, I think in friction, we discussed a few models. Where we stopped exactly? What I remembered, block over block. In that block over block, case 2 means where the force is applied on the upper block or lower block, Nana? Oh, okay, okay. Where that force is applied on the upper or lower? Yesterday model, Nana, what I did not remember. What that model I explained? Force is applied on the upper block or lower block? Means force is applied like this. Is it correct? Or like upper side. Okay, okay, right. Lower not yet started. Am I right? Force is applied like this. Okay, then thank you. So we are in the first model only, right? First model and that to case 2, I think. Case 2 completed, Anana. If the force is equals to the friction, was that completed? If this applied force is equals to FMS, that is equals to mu s into N is mg. Is it completed, Nana? Okay, this is rough. Yes, yes, okay, right. And the surface is smooth. What we took yesterday. This is smooth. Okay, so you are saying that case 2 is completed. Right, then here, if we come to case 3, here, okay, case 3 is, yeah, okay, thank you. If the applied force on the upper block is greater than FMS, then what happens? That we have to see here, upper block and the lower block, free body diagram. Okay, yesterday I think already I drew the forces. It is F, and here friction will act backwards. Here friction will act towards right or left, Nana, on the lower block. If anyone respond in that direction, I will draw. Right or left? Right. Very good, Ishan. Towards right. So this is the friction. It is the applied force. And this is the contact friction. And here, this is the surface in contact. That's why normal reaction is equal to mg. Downwards, we draw mg here. So n equals to mg. Okay. And here this is small m, and I think yesterday we took it as capital M. Yes, right. Coming to here, if F is greater than Fms, then the friction is a kinetic friction. And here they slide not commonly. Okay, no problem, Agok. Here, since good afternoon. Since here, who is this? Vaibhav, SP Vaibhav. Okay, okay. Since the upper block okay slides separately. Why? Because force is more than the friction, Anna. That's why they won't move commonly, separately. Then the accelerations of both the blocks, okay, are okay. This is so simple, Anna. Separately, the accelerations means separately. Already two diagrams are there on the board. Okay, you can see here. In free body diagram, I can write here, it is suppose moving upper block moving with an acceleration a1, lower block is moving with an acceleration a2. Very easy to say what are the two accelerations here and there. Okay. It is moving towards right means I think F is greater than Fk. So F net I write is equals to F minus Fk on the upper block. Okay. That implies on the upper block means F net, I have to write it as small m into its acceleration a1 is equals to F minus Fk. Okay. And the lower block separate acceleration here, F net on the lower block is only one force towards right. So F net equals to Fk. This is on lower block. And on the lower block, this is on lower block. That implies F net is equals to, sorry, mass is capital M into its acceleration A2 is equals to Fk. This is on the lower block. Yes. So what he asked, what are the accelerations? Directly we can say the answer. What are the accelerations here? A1, that implies A1 is equals to, I write F minus Fk by M small m, and A2 is equals to, I write Fk by capital M. Okay. Keep in mind to find out A1 and A2 what we require. First of all, Fk we require. So here we have to write what is Fk. Fk is equals to mu k into n. N is balanced by mg. So that you don't forget. This is Fk. By substituting that Fk here, you will get the answer. Okay. Any doubt in case 3, Nana? Since it is easy, very quickly I completed. Do you have any doubt in case 3? No. Sure? Yes. Very good. Very good. Okay. Suppose in case 2, yesterday what we calculated, if they ask to find out mu s, Nana, then what you do in case 2? confused. What you are saying, I did not follow, Manikanta. F by N. Which F by N? F by mg. I don't know whether you remembered or not. In case 2, FMS is equals to capital M into A. Remember this one, Nana? That is with respect to the lower block, Nana. Not with respect to the ground, Nana. Am I right? Right. FMS is equals to M into A. FMS that you know mu S into N. Okay, is equals to MA. So mu S into N is equals to, usually we write mg, small mg, Nana. Mu S N is equals to small mg. Okay, is equals to capital MA. So mu S is equals to what you are getting? Capital M into A by small m into G. Now you understood this step, Nana? What I wrote here? If they ask, find out the coefficient of static friction. Yeah, good afternoon, Nana. Now you understood. Very good. Very good. This is good. Good. And here coming to this force applied on the lower block. Okay, this case is completed. And model 2 we are entering. In block or block cases. Okay. And if you have any doubt in the middle, ask your doubts, Nana. Why? Because next I will ask and give few questions that you have to solve in the class only. Means you have to say the answers. Okay. That's why once again I'm asking, do you have any doubts in case 1, case 2, and case 3? When the force is applied on the upper block? No, sure. When I ask the questions, will you solve the answer? Will you say the answers? Well, case 1, any doubt? Mr. Ishan? Is it doubt or there is no doubt? Lakshmi Satvika, no doubt. No doubt. Deepali. Ishan? Doubt. Case 1, what is there, Nana? Okay. You understood case 3, Nana? At least you understood this case 3? Yeah, follow. Very good. In case 1, what I told, if the applied force here is capable to slide both the blocks commonly, both are moving commonly. Both are moving commonly means, can I write A1 is equal to A2, at least from the today's explanation? A1 is equals to A2. Shall I write like that? From case 3. Right. Okay, so here only I am writing, you observe. Since both are moving with the common acceleration, F minus this friction. Common acceleration means not kinetic, Nana. That is static or FMS. So F minus F by M is equals to F by capital M. That implies, shall I write here, what common acceleration, no? Both are equal, is equals to A. That implies what you require acceleration. So here F by M minus F by small m is equals to F by capital M. That is, if I write like this, I think you may confuse here. So better I go to the next page. Yeah, here F is equals to capital MA. Second equation is F minus F is equals to small m A 1 A2 nana. What I wrote here. I did not change anything. Observe, Mr. Ishan. Okay. And here what I am saying, if they move commonly, F is equals to MA, and yeah, observing. Very good, very good. F minus F is equals to small ma. So in place of F, shall I substitute here this ma value? So F minus ma, ma is equals to small ma. That implies F is equals to, taking this to the other hand, ma plus small ma. So F is equals to A into m plus m. So common acceleration is equals to F by m plus m. This only I told in case 1, correct? When they move with the common acceleration, A1 is equals to A2. Yes. And what is the friction if they ask? Write F friction from this equation. Right here. Sir, F is equals to ma, sir. Acceleration I found here, sir. That I substitute, sir. F by m plus m. This is the friction. Yeah, yeah, good. So now you understood, Mr. Ishan? Yeah, good. Right. Now I'm clearing everything from here and I'm going to model 2. This is dangerous model. Okay. In model 2, here I am taking 2 blocks, block 1 and as usual block 2. And here the force is now applied on the lower block, F. And again, basically I am considering it is smooth and this is rough. Okay, now this one to some extent, I think yesterday I explained. I explained the pseudo concept on yesterday. No, no or yes. That's why we have to remember what. No. Okay, then right, no problem, no problem. Right, right, right. Okay, then no problem. This is like what you observe here. Suppose this pink color is a person and this black color is a mat. Oh, not yesterday. I think long back I explained. Okay, right. Mat. And if I pull the mat, what happens to the person? He will try to fall back or forward when I pull the mat forward. Falls back. Falls back means he is feeling some force in the backward direction or not? Yeah. That kind of force, what he is feeling, is called as pseudo force. That concept here I am going to explain. Pseudo force, yes, correct. Okay. Now in this model 2, coming to here, explanation. Better today I go in this way. I think you may understand. Here, this is the upper block, and it is the lower block, what I take. Here, the force is applied on the lower block. Okay, like this. Since force is applied on the lower block and there is no friction here, yes. Some other day, I think I explained. In case of bus, suitcase moves back to the back seat. Yeah. Right, correct. Yes, same. That pseudo concept. Here, suppose if I pull forward, here the lower surface is smooth. Surely it tries to move with some acceleration, no doubt. Why? Because here there is no opposing force here at this surface. There is no opposing force means surely it tries to move with an acceleration A. Okay. If its acceleration is A, then immediately the pink color block immediately experience the pseudo acceleration in the backward direction. This is the pseudo acceleration A. Okay. Is it correct, Nana? What I wrote here? Opposite direction. Correct or wrong? Correct. Yes, opposite direction. And suppose if you ask me, sir, what is the force, sir? Okay, right. Suppose if I take its mass is M, upper one, lower one is capital M, like in the previous problem. Then pseudo force will be small m into A. This is the pseudo force. Yeah. Pseudo force is there and the block is ready to slide back or in a tendency to move back. Friction badudha in between those two. Since that surface is rough, immediately where you go ray and opposes the block like this. Okay, friction opposes the motion. Why? Because it is rough. If friction is there on the pink color, immediately on the black color also, yes, I am here also, but in opposite direction. Okay, whatever I drew the arrow marks, correct or wrong, Nana? If it tries to move back, friction opposes. If friction is in this direction on the lower block, friction will be in opposite direction. Is it correct? Correct only. Very good, very good. Suppose by this pseudo acceleration, if the block tries to move back, suppose with an acceleration some A dash or A2. If I take it as A1 and then it is A2. Okay. Then in free body diagram, usually what you write, if I ask this acceleration, what you write? F net here. F minus F or small f minus capital F? Capital F minus small f or small f minus capital F? Capital F minus small f. Very good. So on the lower block, you write here capital F minus small f is equals to capital MA. Okay, one equation. And on pink color, Nana, what you write? MA minus F or F minus MA? It tries to slide back, keep in mind, because of pseudo. So MA minus F or F minus M? MA minus F, very good. So on this block, we write MA minus F is equals to F net. F net is its mass into its acceleration. Yeah, good. This is an upper block. Very good. This is on lower block. Very good. Right? Just keep the two equation in your mind. Okay, why? Because yesterday in my own explanation, if I tried to explain, again, you got some doubt in case one. And you felt very easy when I explained with case 3. That's why better I go with this method. Okay. Now I am coming to here, case 1. Okay. In this case, even though pseudo force is there, they move with common acceleration. If they move with common acceleration. Okay. And the upper block is not sliding separately. Is not sliding separately means what do you say, Nana? A dash is 0, na? A dash is equals to something. It is not sliding. Upper block. A dash equals to 0. Very good. Then thus that point only I'm going to write here. Since the upper block is not sliding separately, I write here okay, no, Manikanta. Here, then A dash, what you told, that I put here, 0. That implies from this equation, from MA minus F is equals to MA dash, I write MA minus F equals to 0. That implies F equals to MA. Do you have any doubt here? No. Very good. And from what we explained, Amol? Means both suppose combinedly move, there is no separate acceleration for this now. So A dash, I took it as 0. If A dash equals to 0, MA minus F is equals to 0, so that F is equals to MA. What's your doubt here, Mr. Amol? Okay, then, right. So it is correct only. Okay, right. So from F minus F is equals to capital MA, okay, I write F minus, in place of F, I write MA is equals to capital MA. That implies F is equals to MA plus MA. That implies A is equals to F divided by M plus M. In one step, I wrote by taking A common and throwing that one to the left hand side. A is equals to F by M plus M. So do you have any doubt, Nana? Here, whatever I explained on the right hand side in this explanation? Understood. Very good. Observe, there is no doubt at all whether you apply the force on the upper block or lower block and moving combinedly. Then the common acceleration is yes, straight away F by M plus M. In both the models, A is equals to F by M plus M. Okay? Yes. And here, if they ask the friction, already I have that equation. F is equals to, what is this? MA. Friction also I have the equation. Okay, this is case 1. And case 2, you know, like in the previous model. Okay, case 2. Coming to here, case 2. Case 2 means about to slide. They move commonly, they move with the common acceleration. but the upper block is about to slide, just about to slide. In that case, still at rest now. So common acceleration without derivation, shall I write it as A is equals to F by M plus M, Nana? Will you accept or not this equation? Yes, very good. Accept it. And here previously we have F is equals to MA na here. So F is equals to MA means this time F is about to slide FMS. Correct, Nana? Yes. FMS we can write the equation mu S into N. There is no doubt. Whereas N already we did in the first page also. N is equals to Mg here on the upper block at this surface. So I think you don't have any doubt. So directly I substitute here N in place of N, that is small mg equals to Ma. That implies, in this case mu S I am getting A by G. Now you observe the difference in the model 1 and model 2. In model 1, mu S is equals to Ma by Mg. Yes. In model 2, this M term is not there. Straight away, we got A by G in model 2. Even you apply the force on the lower block. Okay. Exactly, we got only A by G. Okay, without capital M. See here. Okay, Nana? So completed the second case, Nana. If you have any doubts, you can raise now. Otherwise, I will go to case 3. Shall I go to case 3? Proceed. Okay, thank you. Thank you, Your Honor. Lakshmi Satvika. Case 3, here. Then, in this case 3, like in the model 1, case 3, applied force is greater than FMS. So here going to case 3, F is greater than FMS. That implies both the blocks slide separately. Separately slide. Already I wrote the equations both here. Ma minus F is equals to Ma dash. But here F I write this time confidently Fk. Why? Because sliding. And number 2, F minus F is equals to Ma on the lower block. Capital Ma on the lower block. And here also confidently write it is Fk. Where Fk confidently I write, I think you don't ask any doubt here. Mu k into N, N is Mg. That's it. Over. Okay. Very simply we completed. Right? Do you have any doubt? This dangerous model? The dangerous model, very simple manner we completed in a simple way. Yeah, no doubt. Very good. So these are the 3 equations related to move combinedly. Okay, Nana? Understood. Right, good. Now here, what I'm doing, if I go to one question previously given in exam, okay, that one is, he asked, be ready. You have to solve. Okay. Ready with your weapons. Okay, most powerful weapons. Paper and pen. right? The question is, I'm starting. This is a table. On the table, two blocks are placed. Block 1, above that, block 2. Okay? And their masses, A and B. A is of mass here, means above 1 kg. Below 1, I am taking it as 3 kg. Okay? The coefficient of friction between the two surfaces, I am taking here. Between the two surfaces, coefficient of friction. Okay? That value is 0.2. And keep in mind, the table is not smooth. It is also rough. Coefficient of friction between the table and that one also, better you take it as same value, 0.2. That's good. Okay. Sir, where he is applying the force, sir? Yes, he is applying the force on 3 kg block like this, lower block. Okay. Here, this is the force applied, right? Find, what is the question, sir? F max, maximum value of that force. Okay. F max. For what purpose, sir? So that 1 kg block, okay, does not slide separately. No, no, not sliding separately. Means it is not case 3. Okay. And number 2, keep in mind, there is a friction here. So don't try to apply what we derived in the theory. Okay, Nana? Ready. Very good. Now, solve it. Take the free body diagram. Happily, you will get the answer. Very happily, you will get the answer. If you take the free body diagram properly. I did not explain anything. Just I'm drawing the diagram. So obviously you won't hear anything. I thought that you are doing there. That's why I'm just drawing. Here I'm not getting any answer from not even a single student. So I will try to start here. Yes, okay. Then here, if you are not able to follow, answer to my questions one by one here. On the upper block, normal reaction at the surface, Nana, upper surface of 3 kg. Normal reaction is equals to 1 into G. Is it correct? mg. One by one you answer. Is it correct or wrong? Now Deepali able to hear? Ah, yes, good. Next, number 2. Coming to the lower block means on the floor. Yes, yes, on the floor. N2, total normal reaction. So total normal reaction balanced by mg. Okay, okay. Is it your answer, Nana? I don't know. Okay, we will check it later, Nana. Okay, what is the exact answer that I don't know? Right? We will check it later. Okay, Amo? Oh, even not sure. Okay, then. Right, no problem. I think it is not correct. Okay. Why? Because last year I got different answer for this question. Okay, we will check it anyway. Will you try to say here what will be the N2 value on the floor? Normal reaction is equals to, is it 3G or 4G? Don't say 5G. Yeah, 40 correct. Bah, Lakshmi Gayatri is super correct. Why? Because on this floor means we have to take total weight above that floor. 3 plus 1. Yeah, 40. Correct, Nana. 40 correct. No need to put the question mark. So here 40, that is 3 plus 1 into G above the floor. That is equals to 40. Yeah. 40, I don't think it's so. It is not correct, Nana. Satvika. Okay. Next. Right. If I try to move forward on the 3 kg, first of all, what are the forces acting on the 3 kg and 1 kg? I check, Nana. When I apply some force on the lower block, surely lower block should try to move. When it tries to move, problem is there is a friction at the lower surface. Why? Because it is not smooth. What I explained in the theory. Yeah, friction is applied. So that friction on 3 kg opposes in this direction. Opposes the motion in that direction. So this is friction. Since it is N2, I take it as F2. Okay, Nana? And if the block moves forward, immediately the upper block gets some pseudo acceleration. That pseudo acceleration concept, no need to explain, you know it. On the upper block, pseudo will act in this direction. This is pseudo acceleration. If the acceleration of lower block is A in this direction, opposite direction I will get A. So pseudo force, its mass is 1. So 1 into A, that equals to A. If the pseudo force is there in the backward direction, immediately this surface is rough. Immediately the friction will act here towards right. Is it correct, Nana? What I am going? Yes. Everything correct, I think. Okay, till now. Yeah. This one friction I take, since it is N1, I take it as F1. But it is a common surface for both 1 and 3. Friction drawn in this direction means on the top of 3 kg block, I have to draw like this. This is F1 in opposite direction to F1. Any mistake here, Nana, in my assumptions? No. Very good. So he is asking F is F maximum not to slide means like case 2. Case 2 means this should be equals to F1 should be equals to FMS. Okay. And F2 is also FMS. So I write F1 is equals to FMS means mu into N, N means N1, and F2 is also FMS, that is equals to or Fk, mu into N, N is N2. Okay. So F1, I write it as mu1 is 0.2 here. Both are given same nana, mu1 and mu2 in the question. Okay, I take it as mu1 and take it as mu2. 0.2 into n1 equals to 10 in opposite direction. And here n2 in opposite direction, it is 40. So F2 is equals to, I write here 0.2 into 40. That I am getting 8 and this I am getting 2. Is it correct, Nana? Or any mistake in my calculation or assumption? Deepali, correct only. 8 and 2. Sure? Yeah. F minus 10 is equals to 3a. Exactly. Who put that one? F minus 10 is equals to 3a. More correct only, Nana. Okay. Right. Right, good. So here on the lower block, you can write the equation in the next page. Oh, it's 317, 318. Oh, sorry, Nana. I will stop here after completing this question. Okay, quickly I try to complete. Come to the lower block. Here it is moving forward with an acceleration, means straight away I write it as F minus F1 minus F2 is equals to capital MA. Is it correct, Nana? Thank you. Yes, good. F minus F1 minus F2, both are in opposite direction, is equals to capital M into A. Capital M is 3. So this is equal to 3A equals to F minus, no, Nana. F1 and F2 are 8 and 2, Nana. So 2 and 8, that implies F is equals to here, I have to write 10 plus 3A. Okay. Same way, like in the previous problem, since the upper block is not sliding, what we wrote here, FMS is equals to small m into A, I have to write F1 is equals to 1A. It is not sliding separately, means A dash equals to 0. That's why here A is equals to F1. Are you following that? Yeah. That's what I'm going to say, Mr. Amol. That implies A is equals to F1. F1 is 2. That implies A is equals to 2, Nana. Okay. That implies F is equals to, I'm getting 10 plus 3 into 2. That is 10 plus 3 to the 6. That is equals to 16 newtons. All of you followed this one, Nana? Yeah. Any doubt here? Okay. Right. So better I stop here today. If any questions are there, then we will discuss on Monday. Okay. Right, Nana? Do you want pages here? Otherwise, I will stop straight away. Pages. Okay, right, Isha. Coming to here, first page. Okay, thank you. Sure, Lakshmi Gayatri. I will send the homework questions. Page 2. Page 3. And page 4. Okay, Nana. Bye, Nana. Bye, everyone. If possible, try to solve that assignment tomorrow. I think you have exam, and then after the exam, yeah, you try to solve that one. Thank you. Bye now.